Hello, in this lecture, we're going to again continue with our discussion on Laplace transform. Till now, we've done quite amount of Laplace transform. We've seen the properties, you've seen the inverse Laplace transform. We've also seen a few more other different properties as well, where you have some derivative of a Laplace transform or probably the integral of a Laplace transform. Today, we are going to look back and see a few derivations that I skipped initially. And secondly, I'm also going to do some question today so that it serves as a practice to you. So today's topic is again Laplace transform only. We'll try to finish it today itself. And then we'll take one class on previous year question. And I think that will be more than sufficient. Okay, so let us start with Laplace transform. Just give me a minute and let me wait for people to join in. Let me share the screen. So here it is. So we were doing Laplace transform, and I'm going to play some of the questions again because I thought yesterday or day before, whenever I was doing these things, not many doubts were percolating when it comes to finding the Laplace transform involving the Heaviside function. So just try to do this question. Find me the Laplace transform of h of t minus pi by 2 cos t plus h of t minus 5 pi by 2 into t minus 5 pi by 2. Okay, so this is how it is. This is something we have to find. So what was the so I know that the Laplace transform of a function f t y minus t, and I think it was a h of y minus t is simply y minus c. Sorry, this was c. Okay, this was simply e to the power minus cs into f of s, where f of s is the Laplace transform of f of t. Okay, if you remember, this is something that we have already done. So if I want to find the Laplace transform of this, what I'll do, I yesterday also told you that whenever you have this kind of thing, try to write it in this fashion and take a negative of it. And here you have h of plus okay, this is what it is. And now what it will yield you? It will yield you e to the power minus pi by 2 s into f of s. What is f of s? It is Laplace transform of sines. Laplace transform of sine is 1 upon s square plus 1. And there should be a negative sign. Plus, what will be the Laplace transform of this? This will be e to the power of into. What is the Laplace transform of t? Simply, it is 1 upon s square. So this is how you do the questions. Now let us do a few more based on this will be. What will be the Laplace transform of t square h of t minus of 4? Okay, so how to find this? So yesterday also I told you, whenever you have this kind of thing, try to write everything in form of t minus 4. T minus 4 whole square. Then you have plus, because there would be minus 80, so you should have 80 plus 16, so you should have minus 16. So instead of writing that, I will write t minus 4. This is minus 32. Here you have a 16. So you have to place plus. Okay. So Laplace transform of t minus 4 whole square h of t minus 4 plus 8 times Laplace transform of t minus 4 into h of t minus 4. And then you have the 16 times Laplace transform of h of t minus of 4. Okay. And remember, what is the Laplace transform of h of x minus a? It is equal to e to the power minus as divided by simply s. So and this Laplace transform, this is e to the power minus 4s divided by s cube, and there should be 2 here, right? Whenever you take 2 t square, so the Laplace transform of t square is 2 factorial upon s cube. Then Laplace transform of this is 16 upon s square and then e to power minus 4s. And then you have this e to power minus 4s divided by s. So you have this e to power of minus 4s and you have 2 upon s cube plus 16 upon s square. Not 16 upon s square. Is that right? This is 8. Sorry, sir. 8. So this should be 8. 8 upon s square. And then there should be plus 16 upon s, right? Okay, so this is how it is. Now let us shift our attention to other questions also. A few more other questions also. Try to find me the Laplace transform of this particular function. Try to find me the Laplace transform of sine hyperbolic t divided by sine hyperbolic t divided by t. So I'm giving you a minute. Try to. So how to go about this problem? See, I know that if I take my, so I taught you one thing, that Laplace transform of ft upon t is simply integration s to infinity fs dash ts dash. Okay, where this particular thing, fs is what? Fs is simply Laplace transform of ft. So fs is simply Laplace transform of ft, right? So if I want to find the Laplace transform of sine hyperbolic 2t divided by t, what would I do? See, this is ft upon t now, and this particular thing I'll derive it also today. So s to infinity fs dash ts dash. This fs is simply Laplace transform of ft. So from here I know that my ft is simply sine hyperbolic 2t. Okay. Now I taught you the Laplace transform to this is, I think, if you remember, 2 upon s square minus a square. So s square minus 4. So your Laplace transform of sine hyperbolic 2t divided by t is simply equals to integration from s to infinity. It is, I think, 2 times uh, 1 upon s dash ka square minus 4 ds dash. And you know what is the integration for this? I know this integration is equals to 2 into 1 upon 2 into 2, that is 1 upon 4, ln log to the base e s plus 2 divided by, sorry, s minus 2 divided by s plus 2, from where to where? From s to infinity. And if you take infinity, that will come as log 1, because if you take s common out, that is easy to find, that you can find on your own. So it will be 1 upon 2 negative of, so I'll write log to the base e s plus 2 divided by s minus 2. So if you put the limit first, take s common, so this will come as log 1. So log 1 is 0. So at infinity, this will come as log 1. Log 1 is 0 minus this. So this is an answer to this. This will be an answer to this, and this is fine. Is that clear? Try to see if I want to explain you this. So there is something called as, so if you want to see that also, I'll do that for you. You see, there's something called as change of order of integration that I'm going to use. So L of ft, if it is given as f of s, and ft is of exponential order. This is something that I've already taught you, of exponential order, with the condition that limit t tends to 0 plus ft upon t exists. Then in Laplace transform of ft upon t is equal to integration s to infinity capital fs dash ds dash. So how to see all these things? See, for example, I already know, I have not given the proof initially. Now I'm giving you a little bit of proof. So I know that my f of s is what? F of s is Laplace transform of your ft. And what is Laplace transform of ft? It is 0 to infinity e to power minus st ft dt, right? Okay. What am I supposed to do? I'll take a ds both side, integral both side of with respect to ds. So I'll integrate both sides with respect to s, and this would be integration from 0 to infinity, integration from s to infinity. This would be e to the power minus st ft dt ds. So what I'll do, I'll try to integrate first with respect to s. So what I'll get, integration from s to infinity, e to the power minus st ds, and then with respect to 0 to infinity, and this is, I think, ft dt. So this is something called as change of order of integration. So change the order of integration. I'm first integrating with respect to ds, like with respect to s. What would be the integration e to the power minus st ds? It will be, I think, minus e to the power minus st upon minus t from s to infinity, and then you have this ft dt. Is that fine? Alpna, is that fine? So this is what you'll get. You'll get 0 to infinity, and from here this infinity you'll get a 0, and not this. Okay, infinity will get a 0, and then plus plus. This will give you e to the power minus st. In place of s, you have to place s instead of you take this s dash. So instead of s dash, you have to place s. So I've placed s there. You have a t here, and then instead of writing t here, I'll write t here. So what is the Laplace transform of integration s to infinity fs ds? It is equal to e to the power minus st ft upon t. So basically, integration from s to infinity, you can use to differentiate between the variable and the limits. I've done this way. This is nothing but it is equal to Laplace transform of ft upon t. So this is how you derive the thing. Is that clear to you?
Yeah.
Okay, good. Chalo ji. So this is clear to you. Now let us go and let us see a few more things. So one of the important things that we are going to use is in solving the differential equation is to find the transform of the derivative. So for example, if you have a, so if I'll write that if my function ft satisfies, if my function ft satisfies the following conditions. What are the conditions? Just give me a minute. Okay. Following condition. And what are those conditions? One, that it is continuous and possesses continuous derivative. So it is, the function itself is continuous and the derivative is also continuous. And second, both ft and f dash t are of exponential order. Are of exponential order as t tends to infinity. Then Laplace transform of f dash t is simply s times Laplace transform of ft minus f of 0. So this is how you write it. Why it is very important? See, because whenever you are going to solve differential equation, let's say first order differential equation or second order differential equation, you will be encountered by the terms like d2y upon dx2, dy upon dx. Basically, you will be dealing in with the derivative of the function, and so here it will become quite important for you. This particular formulation will become quite important for you. If you want to have a proof for it, I can give a proof as well. It's no big deal. It's an easy proof, therefore I'm giving you. Okay. So for example, if I want to write, chalo, एक बार start करते हैं. So what would be the Laplace transform of f of t? The Laplace transform of f of t would be e to the power minus st ft dt. Integration from 0 to infinity. And what would be the Laplace transform of f dash t? So Laplace transform of f dash t would be integration from 0 to infinity e to the power minus st, and then you have this f dash t dt. What you can see here, you can take what? You can take the integral of f dash t and you can keep it for the differentiable derivative part. So this you'll see at e to the power minus st ft from 0 to, let's say, beta, with the condition limit beta tends to infinity, and then you have this minus integration from 0 to infinity, or you can say t0 to beta, limit beta tends to infinity. Derivative of this will be minus minus plus e की power minus st, integration would be ft. Is that clear? I have only done integral by parts. I hope it is clear. Then what we'll do, so Laplace transform of f dash t would be equals to, this will be, I think, e की power minus s beta, f beta, okay, minus e की power 0 is 1, so this is f0, and here you have beta tends to infinity, this is plus s. If beta tends to infinity, this is equals to what? This is equal to simply the Laplace transform of ft, right? To the right hand side, this particular. This is Laplace transform of f50. So eventually, what you'll get the Laplace transform of f dash t. What about this? So I'm using it here. I'm writing it here. See, limit beta tends to infinity. What I'll do, I'll take a absolute of it. So I'll take an absolute of it. I know that my function is of exponential order, so this will be less than equal to e की power minus s beta, and this will be some capital M e की power minus alpha beta. I told you on the very first day that function ft is said to be of exponential order. It can be written as m e की power alpha t. So I have taken a mod of it, and mod of it would be less than equal to e की power minus s beta. F beta का mod is less than equal to m e की power alpha beta. Sorry, alpha beta. So I'll write limit beta tends to infinity. I think this would be equals to, this is plus, this will be equals to e की power minus s beta f beta का mod less than equal to e की power minus of s minus alpha. And as beta tends to infinity, this will go to 0 if s is greater than alpha. If s is greater than alpha. So if s is greater than alpha, this will go to 0. कोई मॉडुलस क्वांटिटी कभी भी लेस देन 0 नहीं हो सकती, तो इसको क्या होना पड़ेगा? इक्वल टू 0. इट इंप्लाइज व्हाट? इट इंप्लाइज e की पावर माइनस s बीटा f बीटा की लिमिट beta tends to infinity would be equals to 0 provided s is greater than alpha. Okay, so this particular thing, in the condition that your Laplace transform exists, this particular thing will become 0, and here you have sft. So I'll write slft, that is Laplace transform of f, s times Laplace transform of ft, and minus f of 0. Similarly, if I tell you find what would be the Laplace transform of f double dash t, so a Laplace transform of f double dash t would be equals to what? It is equals to s times Laplace transform of f dash t, right? It will be s times of Laplace transform of f dash t, and instead of f you have a derivative f dash, right? Because now you f if you want to write f double dash t, then the f double dash t is the derivative of f dash t. So Laplace transform of f double dash t would be equals to what? S times, and what is the Laplace transform of f dash t? This is s times Laplace transform of ft minus, you have this f of 0, and then you have this minus f dash 0. So a Laplace transform of f double dash t would be simply equals to s square Laplace transform of your ft minus s times f0 minus f dash 0. Okay, this is another formula. And similarly, if you want to go along and if you want to find the nth derivative, that is the Laplace transform of the nth derivative of a function, this is equal to, on the given lines, s की power n Laplace transform of ft minus s की घात n minus 1 f of 0 minus s की power n minus 2. You will find this as f dash 0 dash 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 minus s f of n minus 2 0, and then you have this I think this should be f dash f single dash. Okay. So this is how you can find your Laplace transform of the nth derivative of your function, given that the Laplace transform of ft exists, and subsequently let's ft and f dash t both okay. So ft and f dash t uh, both satisfy the condition for the existence of the Laplace transform. And in that particular case, the Laplace transform of f dash t is equal to s times f Laplace transform of t minus f0. Similarly, Laplace transform of f double dash t is equal to s square Laplace transform of ft minus s f0 minus f dash 0. And Laplace transform of f and t is equal to s. This is what it is. I hope it is clear.
हाँ भैया.
Okay, good enough. चलो अब एक क्वेश्चन करके बताओ. Let us consider an impulsive force acting on a particle of mass m moving in the straight line along x-axis. Okay, so m d2x upon dt square is subjected to the force ft, where ft is an impulsive force. So I'll write p times some Dirac delta t. Okay, so it is acting at a very short interval of time. That is exactly at t equal to 0 it will act, otherwise it will not act. If this is the case, obtain x as a function of t such that x0 equal to 0 and x dash 0 equal to 0. Try to do this. So I, on the very first day, told you that it is whenever you have this kind of thing, like whenever you have these on the right hand side, the driving forces contain some source term, or probably the driving forces contain some discontinuities. It would be good to use the Laplace transform. So I'll use the Laplace transform both on the side, and I will write that Laplace transform of your x as a function of t is simply, let's say, capital X as a function of s. Okay, so I'll write it here. Um, I'll write it here. Laplace transform of f double dash is equal to what? It is equal to s square. What it was? Sorry, just give me a minute. I think it was Laplace transform of f of t, and you had, I think, minus s times f of 0 and minus s.
That's 0.
Okay, so नहीं ऐसा नहीं था, यहाँ पे कुछ और था. So minus s f of 0, and you had, I think, minus f dash 0, right? So this was the Laplace transform of f double dash t. So Laplace transform of x double dash t. So I'll write Laplace transform of x double dash t would be s square Laplace transform of x. What is Laplace transform of x? It is x simply minus s into x0 minus x dash 0. And x dash 0 is 0, x0 is 0. So I'll only write this. So it is, instead of writing all of these things, I'll write m s square into x. Okay. And then you have this Laplace transform of p. And yesterday I told you the Laplace transform of Dirac delta function is simply 1 if it is stationed at 0. So this is 1 only by the filtering property of the Dirac delta function. So this is something that I know. So what I'll do, I'll write it here. So my x as a function of s I know, and that is equal to what? P upon ms squared. Once I know x as a function of s, then I can find what? I can find x as a function of t also by applying what? By applying the inverse Laplace transform. So this is the beauty of Laplace transform. So here, from here, you can find the inverse of it. So I know that the Laplace transform of 1 upon s square will be equals to what? A Laplace inverse of 1 upon s square will be equals to what? I think it would be equal to simply, I think t. Because see, Laplace transform of t क्या होगा? Laplace transform of t की power 1 would be 1 factorial divided by s की power. Okay, so I'll write, so x as a function of t would be simply p upon m into t. So this is what was required by us. ठीक है? Is that clear? And अच्छा एक काम कर सकते हैं, और चीज समझने की कोशिश कर सकते हैं. So what was the thing? So your particle was subjected to an impulsive force, and because the impulse, there would be a momentum. So here, from here I can write my dx by dt would be equals to what? My dx by dt would be equals to p by m, or in other words, mx dot, which is the linear momentum, is equal to p. So what is the effect of impulse? The effect of impulsive force, p times Dirac of t is to transfer p units of linear momentum to the particle. To the particle of mass. So all of these places where you particle of mass. Okay. So because of this impulsive force, x as a function of t is given by p by mt. So what is mx dot? Mx dot would be simply p. So basically, what is happening? Because of this impulsive force, your system starts to move. Okay. And secondly, what is the amount of momentum imparted to it? The momentum imparted to it is simply p. I hope it is clear. Is that clear? Okay. So now let us do one more property that is called as an integral property. And what is that integral property? So if I say that my Laplace transform of integration from 0 to t, 0 to t ले लेते हैं, यहाँ पे फिर कुछ और ले लेंगे, f that's tau d tau. This particular Laplace transform is given by 1 upon s capital S. Remember this. So given that Laplace transform of your ft is simply capital Fs, then the Laplace transform of integration from 0 to t f tau d tau is given by capital Fs divided by s. Okay, so how to write it? What I'll do, see, I'll introduce another function. Consider g of t is equal to integration from 0 to t f tau d tau. And if I want to find the derivative g dash t, what it would be? See, इसको integrate कर लो तो ये क्या आ जाएगा? Capital F tau from 0 to t, और ये हो जाएगा ft minus f0. यही होगा. मान लेते हैं इसका इंटीग्रेशन ये है. अगर इसका डेरिवेटिव करोगे तो d by dt of gt is equal to d by dt of this, है ना? ये तो था gt. अगर इसका इंटीग्रेशन किया, मैं यहाँ पे लिख के था. ठीक है, तो थोड़ा ध्यान से देखो, जी डैश टी किसका रहा है? डी बाई डी टी ऑफ कैपिटल एफ टी. इट इज कैपिटल एफ डैश टी. और थोड़ा ध्यान से देखो, इंटीग्रेशन एफ टी डी टी, ये क्या होता है? ये कैपिटल एफ हो जाएगा, और कैपिटल एफ का डेरिवेटिव कर दोगे तो स्मॉल एफ आ जाएगा, by the first fundamental theorem of calculus. So from here, if I can write, this will be ft simply. Okay, but I already know that the Laplace transform of g dash t is will be equal to Laplace transform of ft. That is fine, but this will be equals to what? This will be equals to capital Fs. And what this is equal to? This is equal to s times Laplace transform of gt minus g0. And what is g0? G0 is integrating from 0 to 0, so this will be 0. Forget about it. So it is equals to Laplace transform of gt, which is equal to 0 to t f tau d tau and this is equals to what? This is equal to capital S Fs divided by S. This is what it is. So I hope it is clear. The property is clear. This is called as an integral property of the Laplace transform. Now let us move to another important property, which is called as convolution theorem. The property is called as convolution theorem. So it will slightly use interchange of variables. Let us see if you are able to follow it. Otherwise, remember the property at least. If the functions fx and gx are piecewise continuous on closed 0 to infinity, then the convolution, पहले तो देखते convolution होता क्या? The convolution of f and g are denoted by f star g is given by f star g as a function of t is simply integration from 0 to t fx g t minus x dx. इसको याद करो. This is called as convolution. पहली चीज, convolution of a function is defined by this integral. Is that clear? This is the definition. First thing. Is that clear?
ये क्या लिखा है? Functions fx and gx are,
if the functions fx and gx are piecewise continuous, मतलब अगर तुम इस इंटरवल को सब इंटरवल्स में डिवाइड कर दो, 0, इन्फिनिटी को अगर सब इंटरवल्स में डिवाइड कर दो, हर एक सब इंटरवल पे कंटिन्यूअस, ऐसे.
अच्छा,
मतलब ये अजम्पशंस ले जाते हैं. मतलब जब आप लैप्लास ट्रांसफॉर्म डिफाइन करते हो ना, फर्स्ट क्लास में मैंने बताया हुआ है कि ये अजम्पशन है कि अगर आपका फंक्शन पीसवाइज कंटिन्यूअस है और अगर आपका फंक्शन एक्सपोनेंशियल ऑर्डर का है तो उसका लैप्लास ट्रांसफॉर्म डिफाइन हो जाता है. ठीक है. ये जो चीज लिखी है कॉन्वोल्यूशन एफ स्टार जी, इसका डेफिनेशन है, तो ये तो याद ही करना. दिस इज समथिंग यू हैव टू रिमेंबर. इसको कॉन्वोल्यूशन कहते हैं. हालांकि तुम्हारे एग्जाम में नहीं आएगा, बट स्टिल मेरे को लगता है कि पढ़ा देना चाहिए अगर ठीक है मुझे आता है तो. ठीक है. सो दिस इज कॉन्वोल्यूशन एंड व्हाट एंड नाउ आई एम राइटिंग दैट इफ एफ टी एंड जी टी आर piecewise continuous or sectionally continuous on 0 comma infinity and of exponential order, assuming that Laplace transform of ft is capital Fs. I told you these two are the condition for the existence of the Laplace transform, and assuming that Laplace transform of gt is capital Gs, then the Laplace transform of the convolution is simply capital Fs into g of s into capital Gs. That is, Laplace transform of convolution of f and g is equal to the multiplication of the Laplace transform of f and Laplace transform of g. Okay, so let us